joined her PhD in avionics from MIT Anna University. Presently, she is the professor in Aerospace Engineering Department, MIT campus Anna University. She has published around 101 journals in reputed, 101 papers in reputed journals and conferences. She has guided 10 PhD scholars and 3 are presently under her guidance. She is a member in various committees and professional bodies. She received Best Paper Award for her work in 2015 and she was honored with Global Excellence Award from Brazil University, South America. She has expertise in avionics, navigation system, guidance and control and image processing. Also, she is a co-investigator of a TSD SURF funded project worth 27.5 lakhs. She has published 3 patents to her credit. Okay, let me introduce Dr. Anitha ma'am to present before you.
Thank you.
A very good morning to one and all present today, and first sincere thanks to Professor Saktivel sir and Vinoda madam for a very great introduction to me. They have glorified things. So I even started my career as simple as that, from the level of like what you are as a research scholar and the teaching faculty. So you can feel comfortable whatever doubts that you have, and we can have it more like an interactive session rather than making it as a training sort of things. Because this is not actually, the topic is not actually into my research domain. My research domain is on avionics. It's an allied, of course. This is one of my PhD scholars work. This is my allied research domain, and my area of focus research is in navigation systems, mainly focused on unmanned aerial vehicles. And we also do smart irrigation and so on as one of my research scholars work, research and so on. So in that perspective, I'm here before you, relevant to this FDP. May I know, if you don't mind, how many of you are into the teaching and how many of you are research scholars, because I can focus it on that direction in my following discussions. Okay, most of you, fine, thank you. Thank you very much. I think am I audible till the end? My voice is when the session goes, it will become
Record.
Okay, fine. Hello. Yeah. Because I myself will be audible definitely till then, because I am used to take up classes for 80s and 90s students and so on in the initial. Now, since that we have been put on to PG after becoming into professor and so on, we have been allotted with PG students. It's a crowd of 10, 20 and so on. Otherwise, it will be a crowd of, I taught them in the electronics department where there will be 80 plus and so on. So I'm very comfortable addressing a crowd of 80 to 100. That's why I said. That's fine. So that is my research area, avionics. Avionics is aviation electronics. So I am in the Department of Aerospace Engineering, MIT, but I am not an aeronautical engineer. I did my UG in EEE, Electrical and Electronics Engineering. Always, like all of us, I have always a fascination towards this flying things, aircraft and so on. So while I was doing my PG at IITM in Control and Instrumentation, there was certain specific electives on guidance and navigation guidance and control. So I did that course under Professor G.T. Manohar sir of then, he got retired and so on, right? So he used to take it in a very fascinated way. So the way he took up the classes for us, the flight control systems, guidance and so on, I was very much attracted towards that domain. So when I completed my PG, even then when I was offered with industrial placements and so on, I wanted to come for teaching, and especially I came over to MIT because it has got aero department where we have the division of avionics, which does this flight control guidance and so on. That is how I landed into this division. So with that I did my PhD in the vision-based landing. It is like integrated, INS and vision integrated system for landing of unmanned aerial vehicles. Unmanned aerial vehicles, in the sense, my PhD work is not for the smaller bird, it's for the bigger bird that you talk about in terms of hundreds of kgs. For that vehicle, how to land and so on. This is with ADE in collaboration with Aeronautical Development Establishment, Bangalore, DRDO concern. We did that work, and that is how I did my research. Following that, most of my research scholars are doing it in the domain of avionics. And one of my research scholar, he actually started in the avionics domain, and due to some reasons, he got placed with some other place. So he was not able to interact with our lab continuously. So he was not able to do about in avionics. So he took up a convenient topic of doing something on the squad related things, quadcopters and so on. So since that nowadays it is very much sought after. These captions are very attractive nowadays. AI, wherever you put on, you will get projects, you will get paper through and so on. So because of that, he selected the topic of integrating AI, integrating IoT, machine learning into agriculture. So ultimately that is the field now, right? Whatever you relate to agriculture, that takes up more visibility, right? And that is how we landed on to this particular research work. So that's where I am suitable for this FDP, because of that research on AI integrated with IoT and machine learning for the agricultural thing. So he did it on smart irrigation. By the end of this session, I'll address that. Okay. So I have planned this session in such a way that as the title indicates, it is like a precision agriculture with the drone technology. So I will address first what is this precision agriculture, what do we mean by that, and what is drone technology. As you are all aware of, in a session I cannot justify the whole thing. I can just give you a briefing of what is precision agriculture and what is the basics, introduction for the drone technology, and then based on the research that we had carried out, I will tell you like how this precision agriculture been taken care of by the drone technology in our research. Okay, that is how my focus of this session will be, right? So this precision agriculture, of course, it's more of, as you are all aware of, it is to do about like how the technology brought into agriculture, smart agriculture, right? That is your precision agriculture. So I will address like what is the perspective, from our perspective, what we have understood as precision agriculture, and how do we claim that what we have done is a precision agriculture, right? So that I will tell you, and then see what is the need for precision agriculture actually. So when we talk about whatever topic, first we have to know about the justification for it. Why do we study that? So why we need to know about this, we need precision agriculture, and why we need it in India, and what is the status of precision agriculture in the other countries, and compared to that, what is the status in India. Okay, so what are the challenges that are being with precision agriculture? These things probably in the last 4-5 sessions which you had, might be you would have gone through such introductions also, because it is not anything to do about research, it's in standard content. So that might be a repetition. So anyhow, I'll give you a briefing on that. And then I will enter into drone technology, where I will focus about what is actually meant by a drone, and what is the difference between why do we call it as a drone, or sometimes we call it as an UAV, sometimes we call it as an UAS, right? So what is the difference, how are they being classified, and basically how will you build a vehicle, how you can build a vehicle, what are the components, need for those components. That's how I'll give you a just briefing on to the drone technology. Then we will move on to how this drone technology being used for the agriculture, which we call it as the precision agriculture. Right? So this precision agriculture part that we have been going through will be an introduction. Right? Yeah. First we have being used mixedly, like precision agriculture and precision farming. Right? Everywhere we could see about it. So I first wanted to clarify exactly what is this precision agriculture and precision farming. So precision agriculture, generally what do we mean by that is, it is the principle, right? And how do we practice that is what we refer to as farming. That's what I have understood. Okay. So I start with that in that way. So ultimately what we want is like the agriculture to be sustained, right? We want it to be, and we want to motivate more youngsters to come over to the profession, right? Agriculture, so that it can be sustained. So to attract the future generation, the youngsters into this domain, you need more technology to be brought into that, okay? And the technology has to be taken care in such a way that it should not harm the nature, it should not do any harm to the environment, it should not do any harm to the personnel and so on. So that has to be taken care of. So in that perspective, when we make it, we call that as a smart, right? Smart work, right? So sustainability in agriculture through precision agriculture. That's what is our focus is, right? So precision agriculture makes farming interesting for future generation. That's what is our main focus on, right? So we have to make more youngsters come into this domain of agriculture, right? So sustainable agricultural production, what do we mean by that is judicious management of all the resources, input or water, land, whatever we talk about. So it has to be ethically managed, right? So that is the total aim behind, okay? So in that perspective, to give a definition of what is in precision agriculture is, it is the management strategy, right? So management strategy, management of your products, agriculture related products using the technology, right? That's what we exactly mean by this precision agriculture, which uses the cutting edge technologies. Of course, we are not using cutting edge technologies into agriculture, right? When we talk about space applications, aircraft, spacecraft and so on, where you could see whatever you are talking about, today the peak, whatever the technology is, it will be there onto the system. In a spacecraft or in an aircraft system, you talk about whatever you are saying it as in current technology, so that will be there. But it is not so with agriculture. We are just developing how to bring in technology into agriculture, right? But then the idea of precision agriculture is to bring out the latest technology over there, okay? So because if you take up for an example, the title itself, the drone technology, it is there for so many years. Because I did my PhD somewhere around 15 years back. By then I did it in unmanned aerial vehicle only, and now only it has been spoken more about on that aspect. So we can't say that whatever is recent being put in, we are in a developing stage. Right? So that's the perspective, but we have to bring in all the cutting edge technologies into the agriculture. So then only the total precision agriculture term will be justified. Okay? So I would like to take up an overview, like I am not going to teach you and so on, because you are all in the teachers and research scholars level. So what I felt over is, when we talk about something, I have to tell you like what extra information other than what is available in the book has to be conveyed to you, so that you will convey it to your students, right? So in that perspective, I'm not going to talk about how it is done, algorithm and so on, because that you have been given out with various sessions, hands-on and so on. See, for an example, IoT, I'm not going to talk about how IoT is being implemented, or ML, whatever on the database, or how it is being, learning process being taken care of, supervised, unsupervised. I'm not going to touch on those parts because you have separate sessions on that. I'm going to take it in an exclusive way, in such a way that what are the other informations that you can convey to the students which will motivate them to this domain, right? So that sort of an information is what. And for the research scholars, of course, you have to get motivated towards. So many of my own research scholars, they have become entrepreneurs taking up this as a profession. So I am going to give out certain companies and so on, which I am not supposed to give you. I will, off the session, I will give you the private companies which have been run by my own students who build these UAVs, give training and so on. So they have taken it as a profession. And in our department, we also have a Center for Aerospace Research. So it is a separate center which handles all these research activities in our department, where we have an RTO, RPTO, CASR RPTO. You can go through the website, you can see over there, it is a separate website, is available over there, where flying the drones is like you have various categories. Beyond and nano size and so on, in the small and medium UAVs, you need, like driving, you have a license, right? Even for the two-wheelers, we need license for driving. So similarly, for flying also, you need a license. Okay? So earlier when we started, that awareness was not much there, and people are just like that flying. But nowadays, the DGCA, Director General of Aviation, Civil Aviations, now it is giving rules that even you can get arrested if you are flying it without the knowledge, right? Which are the proper piloted license. If you are trying, you are eligible to get arrested if you are going beyond the nano vehicle. Nano vehicle is less than 1 kg, like 600 grams, 500, 600 grams. If you are flying, like what they are doing it in the marriages and so on, no? For photography and so on, they are doing. Those things doesn't require any thing, because it doesn't harm people, right? So, but then if it is slightly bigger and so on, if you are doing it for different applications and so on, you should have a knowledge on where you have to fly, where you are not supposed to fly. There are zones where you can fly, where you are not supposed to fly and so on. So those awareness are required. Those things will be given as a part of the certification. So it is by DGCA approved certification is provided here at MIT. In CASR, they run a separate division where you will be given out all these theoretical things, and you will also be given out training to fly, medium to large drones and so on, how to fly and so on, what are the parts, how to assemble, how to reassemble, how to pack them, what are the applications that you can make use of. Those things they are giving out, of course, in a charged way. Right? Now, in an optimally charged way, they are providing it, but it is in DGCA approved certification they are giving out. With that, you can fly anywhere you can fly, and you can take it as a profession, right? So many youngsters, especially the student community, they'll be very much fascinated towards drones. Nowadays, even at MIT, we see people are not talking about aircraft, people are not talking about spacecraft. All these students are into the project which will be related to UAVs, drones, UAVs and so on, right? So students are more fascinated into that. So in that case, you can advise them, they can even take it as a profession, provided they have a proper license and so on. You can guide them for that, okay? So those informations also I'll provide you with that. What is the procedure and so on. So now precision agriculture, as I've told you, it has to more efficiently use the crop inputs and the following so-called 5 R's. General rules will be there for every system. So for precision agriculture also, you have some 5 R's which has to be followed. Right input, right amount, right place, right time, right manner. Okay, that you have to verify. If you are following this, then you will carry the agriculture that we are doing is a precision agriculture. Right? A right input is like finding out what exactly the plant requires. If it is for typical agricultural purpose and so on. See, what is the nutrient it requires. For an example, if a plant is deficit of nitrogen, whatever pesticide or fertilizers you get on, that more, except for this nitrogen, if you provide everything also, it will be not able to bring out to that level of with the nitrogen and so on, right? So you should know what exactly is required, what is deficient for that particular plant. So you have to give the right input. So identifying the right input, what is required. How we will identify? First thing is that you could analyze the soil, right? So what are all the minerals of the soil and what is required for that particular plant and which is not available in that particular soil, what you have to provide. So those things you have to be aware of, right? And if it is being affected by the disease, what type of a disease it is and what is the treatment that is required. It could be either organic or chemical things and so on, fertilizers and so on, but exactly what is required and so on. So that you have to identify. So right thing, you have to, right input you have to identify. Now that, how do we identify that? So the nutrients about the soil and so on, seeing that we will not be able to identify. So we need sensors for it. So proper sensors which will give the quality of the soil. So there comes the first technology, okay, sensor technology, where we will identify what are the nutrients present in the thing and what is required for the plant and whether it is available and what we have to give. So that you can identify, first thing. Second one is the right amount. Particular nutrients, if it is goes higher in phosphorus requirement, of course, potassium requirement, nitrogen requirement, they are all required, but there is a limit, right? Allowable limit for every plant. So that you should be aware of. You should not give it into an excess, okay? Like Amarda Manalu becomes Nanjan, right? So you have to give them in a required amount. So that you have to know the right place. What is that soil condition? What is that place, environment? How will be the weather over there? What type of a plantation it is, right? What is required? So those things you have to see about, okay? That you have to identify. So you should know about the temperature of the surrounding. You should know about the humidity of the surrounding, based on which you can give the watering level to the irrigation to the plants and so on. What is it? What type of an irrigation is required? Whether you have to irrigate, you have to keep the soil moisture, or you have to spray something into the leaves to keep it and so on, right? So if it is a floral thing, you have to maintain the spraying that you are doing, control the spraying that you are doing. So those things are the place, okay? Right place where you have to do this job, and then right time, right? When you have to do it, right? So those things, and then in a right manner. Now that is what I said to you. Certain things will require a thing on the soil which is required for the root. Certain things will be for the leaf. Certain things will be for the fruits, flowers and so on. So where it is required and how to provide that for that plant, right? So in a right manner you have to provide, okay? So that is, these are the things which when you satisfy these things, obviously your precision engineering is being taken care of. You can call that agriculture as precision agriculture, right? Fine. So that way. So that's what is finally being defined, information technology based, right? IT comes into in the form of all the other algorithms that we make use of with IoTs and so on. We do in wireless communication. Some sensor in the ground measures something, gives it to a control center somewhere else and so on, being transmitted. So all those things comes into some picture. Information technology based, so that is the first word that we emphasize on that. Better management system, it's a better. We don't claim that as a best because still we could move forward. Okay, better management system that identifies the procures, right from the procurement, procures, analysis, manages, and then variability, natural variability. Okay, this variability is a very important factor. At what rate? Variable rate management. So that is a very important thing that has to be taken care of, right? Variable rate. Because you cannot say that right? You can't make that. If it is for this particular plant, this is the amount and this is how you have to do. For the same plant, you have to do, for the different plant, you have to do it in a different plant. The same plant in a different place, based upon the environment, you have to change amount. In the same land itself, At some layers, if it is slopey, at some part you will be having the moisture content and so on. Some places it will not be that enough and so on. So you have to make it in a variable rate. You can't make it as a uniform thing like what we do it in the class. We divide the class students brighter and average and slow learners. We classify. So we cannot just like that give out the information to in a common way to all the students in the class. We declassify them. We have to have a variability here at the agriculture also. That's what's variable rate management. Okay, so that is an important factor. So that has to be taken care of. With all those things, we get an optimizes productivity. Ultimately, that's what is required, right? In the car developer, நம்ம பெரிய பெரிய டெக்னாலஜி எல்லாம் ஒரு அட்வர்டைஸ்மெண்ட்ல ஸோ தே கீப் சேயிங் இந்த வண்டியில் இந்த டெக்னாலஜி இருக்குது அந்த டெக்னாலஜி இருக்குது வி ஹவ் பீன் புட் அப்படின்னா இஸ் தேர் எனி கொஷின் அப்படின்னா உள்ளேருந்து ஒருத்தர் கேட்பாரு ஹவு மச் வில் பி த மைலேஜ் இட் வில் கிவ் அல்டிமேட்லி இட் வில் பாயில்ஸ் டவுன் டு ஹவு மச் ப்ராஃபிட் வி கெட் அவுட் ஆஃப் இட் ரைட் ஸோ தட் இஸ் த இம்பார்ட்டன்ட் திங் ஸோ வி ஹவ் டு இன்க்ரீஸ் த ப்ரொடக்டிவிட்டி we should increase the profit income that we earn from that ultimately. So that is how. So productivity, profitability, and this has to sustain, right? We don't have an escape for agriculture. Any other domain we can have an alternative. சாப்பாடு தவிர ஒன்றும் பண்ண முடியாது. We need food, right? So sustainability, what could be done to have a sustainability and which protects the land. Sustainability, all these things we have to take care of, provided we don't spoil the resources, natural resources. We have to conserve them, right? With that idea, we have to get all these things. So that has to be kept on mind. That is why, nowadays, the spraying and other things which is being done with, even they are doing things like, it is not just like chemical manures, fertilizers and so on. It is like organic things also, how to be taken over to the plants and so on. Right? Because they will not be in a liquid form that things in pores and other things will get stuck with, but they are finding out solutions for that so that you can give an organic fertilizers also, manures and other things to the plant. Okay? So that has to be taken care of. We have to conserve the land, water, air. So that should not be polluted. So that has to be taken care of. So I have spoke about what is this right rate, right input, right time, right amount, all those things. So I skip off all those things. Fine. So exactly speaking, what is the conventional agriculture and what is the precision agriculture? Of course, I have covered over there, but still it is as a slight point. I will cover it over there. So it is like an manually we'll choose a location, right? எனக்கு இந்த இடம் தான் இருக்குது, இங்கே எனக்கு 2 ஏக்கர் இருக்குது, அதனால் நான் இதில் பயிரிட்டேன், right? So that is what we call it as a conventional thing. But finding out whether will it be suitable, that particular land will be suitable for this thing, and how about the geographic and other information about that land and so on, having an idea into that and then doing an agriculture. That's what is your precision agriculture, using GPS, GIS instruments, bringing in technology into the system, not everything manually, right? Making it an automated system, right? That is your first point in your precision agriculture. Then adding fertilizers and chemicals based on previous experience. That's what we addressed also, right? Enga tata vandu idha potaru, enga mama vandu idha potaru. It's not that way, right? What is exactly required and so on, finding out with soil engineers are there, right? Analyzing and then adding on to that, okay? And then next point is the conventional way of scrappers and levelers with the carts, bullock carts and so on. So nowadays we have the laser guided levelers and so on, right? All mechanical things are being replaced by automated things, right? Seeding, planting, irrigation. Irrigation is the one which I am going to address at the end as one of my research work, which is smart irrigation. There are so many things involved in just giving out water to the plants also, right? So that is in separating. Of course, we have been into this drip irrigation and so on to optimize the usage of water and so on. That also being made intelligent, right? So that is what we are going to address at the end, which is smart irrigation. Okay, so that is being included in the thing. And using drones for what? Could be either spraying something, either fertilizers, seeds or whatever it is, and also in the extended way, as you had so many classes on machine learning and so on, you would have gone through, right? So the drone will capture about the images. From that you can do a processing, right? What is the health of it? What is the amount of stress the plant is having, the leaf has and so on. That you have so many databases now available for individual plant. One of my students has worked on tobacco plant because it was nearby for his research, the nearby field that he had with the tobacco, so he has done a research on that. He has created a database, right? Because so for certain plants you will not have a database to follow, wherein you can create your own database and then you can apply your algorithms, right? The machine learning things that you are applying for. That's way bringing in drones into the thing, right? And harvesting. Robots are used for picking up and so on, so many things which you are seeing nowadays. So everywhere things are coming in. Now we have extended to a point that you will have a robot, ground robot, you will have an UAV and they will be coordinated and they will be connected and the information will be processed through the internet. At a control station, commands will be given over there through the telelink and these vehicles will be guided, right? So that is where we are, right? So we had robots for doing this job, we had UAVs doing some job, we used the photographs and then did something on IoT. We have done and implemented artificial intelligence into the thing to find out how much things will be required, what is the status and what has to be done for it and so on. Now all these things have been put together and ground robot will be there. It will be doing the survey on the ground because soil thing cannot be analyzed by an UAV. Whatever is the mineral present over there. Of course, if you have hyperspectral cameras, you can do a good, right? You can do a good, but always you will not be able to put up an hyperspectral camera into an UAV, right? A farmer, and a simple farmer who wants to do things in a low cost cannot put an hyperspectral camera and do an image processing over there. I think you are all aware of hyperspectral camera. If you go for it, it will be more than tens of lakhs and so on, right? So you will not be able to afford, right? So in such cases, we need a simple solution, but an efficient solution. So what could be done is something which on the ground, a ground robot will be taking care of, and then you will have a drone also, right? They will be doing and telelinking. They'll see to the health of the leaves and fruits, flowers and so on. The ground robot will take care of the soil health and so on. And finally they will communicate to the ground station where the things are being processed. You have so many machine learning algorithms and so on, which will run and tell you what is the health, what is the status of the soil, what is required and so on will be suggested. And to the next extent, we have also developed an application, mobile application. You have an app, right? It takes up, I'll show you with the outputs also. It will take up like an input from the geographic GIS system that the weather forecast, right? When you are doing an irrigation, we should take care of that also. If you do an watering today and after 2 days there is going to be a heavy rain, there is no need of watering it today, right? So you should see to that whether we have any forecast for the next 3 days, whether we have a next forecast of rain for the next 1 week and so on, based on which you have to do and water, right? So that being integrated into the thing, right? So that's where IoT comes into picture. So you will take up the data from the weather forecast, right? And you will do and you will take up images using drone. You will take up the soil features, the temperature of it, humidity of it, the minerals of it, and so on. So all these things, data will be processed by machine learning algorithm in the ground in the control station, and taken will be given to you. And the mobile app will also alert the farmer that if the humidity condition, the moisture content goes below a particular level and so on, it will give a warning. So that, and you can also make it an automated thing. That is, it will give a warning to the farmer as well as it will switch on the watering system, right? It will be automatically, the watering system will be switched on. Okay, so that is how we are in a highly automated way. Okay, so yeah. So need for precision, of course, the population is increasing, right? Indian population is increasing. Some numerical data. With that only we have to analyze things, right? In an engineering way. So we have sources depletion of water resources, obvious things which are very much known to us, for which we need an alternative. So your precision agriculture is one such alternative. Okay. Why do we need it in India? Right? Because here only we have a more population increase, the rate of increase and so on. Right? So obviously to sustain, right, to have an agriculture being extended, to have an sustainability, we have to attract all the technologies into that, so that you can attract all the youngsters into this domain. And for those reasons you need the final last point, which I will keep on repeating. Precision agriculture is essential in order to address the poverty alleviation, enhance the quality of life and food security. Okay, for this we need. Okay, so that has to be. So and almost it says like we have 50% of the country's workplace and 70% of the rural families, they depend on agriculture, right? And 50% of the farmers are having, the problem is, next problem that has to be addressed is this way, right? Some few acres of land, right? And a farmer who is having 1 or 2 acres cannot afford for too much of technology, right? When human resources are easily available, he will call somebody to do that job. When you want to put up an technology into that, how affordable it is. So the total idea behind this, all these things which the government is bringing in so many plans, is that to bring down the cost of having a technology into the agriculture, right? We have to reduce it, right? Even now, I will also talk about certain things wherein the spraying and other things which you cannot afford. Some farmer who's having doing an agriculture with somewhere around 4 to 5 acres or less than 10 acres will not be able to afford for a separate drone for doing all these purposes. Will not be economical, right? So you need to have certain solutions wherein the small farmers can also have an access to all these technology, right? If that is achieved, then you can easily achieve the precision agriculture. Okay. So the scope, what are all the government plans that have been brought in? The Project Directorate of Cropping System Research and the Tata Kisan Kendra, they all support for the development of this precision engineering. And of course the ISRO, so they are also doing it because they are providing us with the images, right, to do about, because they have an high resolution multispectral cameras available with the satellite, which gives you the thing. But then what is being analyzed by a drone with a simple camera over a few feet meters of height will be better compared to what is being provided to us by a satellite. Okay, so that way it is much more efficient. Okay, so we are, but the satellites are providing us information both on weather as well as the other informations. You have to classify, you have to segment. That is very important in your precision agriculture. You have to segment the land, right? Some part of the land will be like this, soil is something which is suitable for this, some of the part will be suitable for this and so on. So you have to segment them, divide them and do about the job. Okay, for those things, for segmentation and so on, we will use the satellite based equipment. So ISRO is also contributing in that way. Okay, and where are the other, all the other government schemes that are focusing on to develop the precision agriculture. Tamil Nadu Precision Farming Project, they have an exclusive project being implemented and to make the farmers. So ultimately the benefits, these are the things that you want to achieve, as I told you. Increase the crop field, and which in turn will increase the profitability and so on. Okay? Yeah. Again, which gives an plays a main role of 27% of our GDP is based on agriculture. So we have to focus on this. It's not just for the sustainability that we are talking about, for the economical growth of the country also. We need to focus on agriculture. It's a backbone, right? So the other way about the labor in farming. So what are all the issues that are associated with that? High wages, as you are all aware of. Now the labor affording to that has become very difficult, right? So, and the availability also has been reduced. So how many of them into the agricultural work and so on is also been reduced. Okay, so we will not get them in time. all the technology is being implemented, and when the technology says water it this time, this much, a person should be available for doing it, right? So when that is not available, all this research goes waste. So you should also need the proper technology which can do things in an automated way. So that way, so non-availability in the time of need, even if the labor is available, they were not available on the time when we require it, right? So all the time available is another problem. And the choice of necessity, so it is another way that it's not like the earning of the farmers, the people who are working on the land is being granted. It is not that way. See, certain things are also on the health perspective of the human resources who are working on that. See, manures, no, the fertilizers and so on which they are spraying, it's very dangerous, right, to their health. They cover and so on, even they put about and so on, they are being affected by so many other illness, right? So it is like they dilute it too much. See, for an example, if it is 100 grams of fertilizer, along with that they will put up so many liters of, for somewhere around 10 liters, they will put 100 liters, okay? Dilute them, because that itself will be very much strong for the human being, right? And they will be spraying it on that. So making the 10 liters into 100 liters, so it will take that much time to finish off all the 100 liters. Instead, when you are doing it through drone, it is not 100 liters, we have 10 liters that you have to put, and you need not have to make it into 100. That 10 is being reduced, and now so many farmers, they by their experience, they are saying it is being almost like 4 to 5 is again an increased level, I am saying. Less than 5, it is not even 50% of the same fertilizer is required. And they don't dilute it with 100 liters, even half of that, less than that. So that much concentrated thing, they can spray it exactly on the plant, okay, leaves and so on. So they are spraying it in such a way that it's very small particles, nanoparticle sort of thing, so that it will be exactly observed by the leaves. You know, the structure of the leaves and so on, the pores and other things will be there. So rather than spraying a diluted thing so many times into that, wherein there is an escape that it could go to the soil wastedly, which it is actually required by the leaf, right? Whereas with the drone technology, when you are spraying it, it will be exactly given over to where it is required, okay, in a concentrated way, so that it will be immediately absorbed. To the extent that even after 2 hours, if there is a rain, that will not affect. See, people used to say, it will be totally gone and so on. So that those things will not be there, and the other illness and the other risk of the human being addressing the fertilizers directly is being saved out of this technology. So that way, it is the replacement is a good thing, fine. The next
effect
one.
of wind will not influence.
Yeah, of course. See, it is like what type of a drone it is, how much is the stability of it, how good the pilot is, the ground pilot is. All those things will be influencing on how you handle the vehicle. Whatever it is, almost like some 25 to 30 kilometers per hour sort of speed of wind, the vehicle can easily manage. Beyond that only, you will have a problem. You cannot make use of, and you cannot do it during rainy hours and so on, because the motors and they are all they are properly insulated and so on, but then you have the control boards. It's totally electronics. So when it is highly pouring, you will not be able to use this and so on. Of course, when it is highly pouring, nobody is going to do it. So that is not an issue, right? So you will be able to make use of it, right? Energy. So it's the fuel cost and the energy saving method should be cost effective ultimately, right? So that has to be made efficient. And how much is the water? Quantity and quality of the water that is being given over to the plant, that has to be optimized. So these are the things which need to be addressed with whatever technology that we are talking about. So these are the things which comes under the tools. One is GPS. GPS will tell you the location, right? Where exactly this land is, and what is the geographical map of it and so on. GIS will tell you what type of it, other associated information, all real-time information, stacked in layers, okay, will be provided by your GIS. And this variable rate technology is what I told you. right? You cannot do the same thing for the whole thing. You need to have a variable rate. To what and how much, right? Auto steering guidance or the automated systems for leveling, and then field monitors, water management. This is what I'm going to talk about, smart irrigation, and remote sensing by satellites. Okay, this is what I send you. You will have an information from the satellite itself about that place, that land, how is it, and so on, right? And also you can have it with UAVs and drones. Okay, so weather stations, which will give you the weather forecast, whether you will have rain for the next 3 days, weather in next 1 week, and so on. So that weather forecast, and the mobile and IoT and other associated things, which will do the processing and will give you the information. Okay, so that's all it is. And when we talk about GPS, this is not required, but I just wanted this. These are my areas of research, so I cannot skip it just like that. So I had included a slide onto that because I am into the navigation systems. Okay, my research domain. So as you are all very well aware of the satellite communication system, where we have all these are satellite communication systems. What we talk about: GPS, GLONASS, Galileo, and this Medu, Compass, and IRNS and Gagan. Right? So it is the satellite navigation system for different countries which being used. Right? So as I've given over, GPS is by US. It is totally installed, maintained, controlled, everything financed, everything is by the Department of Defense of US. They have the total control of it. And they give access to all in the world. Right? GPS, we are all using GPS because free of cost they are giving you the service. And it is free of cost because they don't have an idea who is using it. Otherwise they could make a charge on them. Since that they don't know, see, when it is transmitted from the satellite, you don't have a control on the signal, who is using it and so on. So that is how, so he is not aware of who is using that, so he will not be able to charge the system. Okay, but then they are giving it. But they are giving it in 2 different bands, as you are all aware of, L-band, S-band, and so on. 2 different systems. Standard positioning system and precise positioning system. The standard positioning system course of position is what being given to all the others, and their Department of Defense, DoD of US alone, they use the PPS system, precision positioning system, which will be down to the level of centimeters, level of accuracy which they will be able to acquire. That they are not giving access to others. It's only being used by their defense thing. And we have, all others have the access only to standard positioning system. But that accuracy itself is reasonable, so we are using it. But it comes into picture where we need our own. All the other countries like Russia, USS, when it was as USSR, it was GLONASS. Okay? And then Europe is having Galileo, and they have, why people are building a separate system is for 2 reasons. Number 1 is, they don't give access to the precise positioning system. They give access only to the course of position system. So we need precise when you are, especially for the aviation applications, where we have to land. It should be exactly, right? We cannot have an plus or minus of meters of resolution and so on. So we cannot afford to. We need down to the level of centimeter level of accuracy in so many applications, where the target is, where it has to be attacked and so on. They need very precise location, right? For which we cannot depend on GPS systems. So we have to augment them. We are doing some augmentation system also, as you would have aware of LAS and WAS, local area augmentation system, wide area augmentation system, all those things we are using it, okay? So with the GPS system, and then we as our country wanted to have our own satellite based navigation system when we were being denied by the US for saying the enemy locations during our Kargil war. Then we realized that, okay, we need our own system. We cannot depend on these people. It is by that time, at the end of Kargil war only, we came to a conclusion that we need our own satellite system. For defense application, we cannot depend on something which is totally being controlled by another giant, right? So for that application only, we started with this, and we are into this, okay? This IRNS is here, it is again navigation based satellite system with Indian regional. Okay, navigation satellite system is what is your IRNS, and Gagan is augmenting, geo augmentation, right? with our own system, okay, augmenting the system, which we call it as augmentation systems and so on, okay. So these are the two projects of India which is on progress. Not into fully application, we are in that test mode and so on. That is why still we are using GPS in our mobiles and other things. So for naval applications, for army, for defense applications, we are going in for a separate system. We call it as a GPS denied navigation, right? Most of our systems are dependent on GPS, right? So we cannot depend on one thing which is totally being controlled by another thing, right? So especially for that, we are into a special domain of navigation, which is in a research level. It is a highly preferred area, which is GPS denied navigation. And there are so many other reasons also. I think you will be aware of. You cannot have a GPS access when you are inside any building and so on, where you don't have a line of sight with the satellite. It is accurate and so on, and only when you have a line of sight with the satellite and so on. Let me not go out of the scope. So the GIS provides these are the layers, fine. So it gives you the mapping of the location, right? So these are the informations which we group together as the GIS world. The real world, you can see them in various layers. You can see them as an imagery, elevation, how much elevated from the sea level, what about the transportation, address of the boundaries, what. So you can divide the real world into various levels, okay? So much information to that particular place, okay? So what are all the informations being provided by that? We have exclusive softwares which we have gives you this. ArcGIS is one of the app that will tell you like how, what are the other informations that you can get out of when you feed onto that land. Will be the, how much will be the yield and so on. So all these informations you can get out of this ArcGIS map, which is it gives you the SMS map, which is a yield map with all the legends. It will give you what is the quality of the mineral and other things. So this is what we when we talking about the variable rate population mapping. Okay. So variable rate population mapping, the same land you can segment them, right? So how the moisture content is in one place. We could have seen yeah. So when it is acres of land, one part of it will be having, the other part will be having a medium, the other part will not be having a rain at all, right? So the moisture content varies. So you can do a segmentation based on just for that, and based on which you can do the decision. It's as simple as that, like how we have a fire control and so on. Just an example. So temperature sensor detects the heat. We have at all the official places and so on, wherever smoke detectors and so on, when the smoke is detected and so on. So sends the detector signal to the control, and then control will in turn will give a command, and then you will have sprinklers and so on. So in a process, okay, an open loop process. So likewise you can do it, you have it for the agriculture also. So the agriculture, you will see what is the amount of energy that you are harvesting, and in the same way you are seeing what is the moisture content, humidity and other things associated with the soil, what are the nutrients of it you are finding out, and you have the irrigation system for it, and you do an analysis onto the soil, you see the climate, you see the crop, you look into that through imagery, how the health of the crop and so on, through image you see the crop. All these informations are being fed over to a processing system which does this processing, which will be stored about in your cloud surface, and you will do a smart service, you will do various algorithms, and you will give an input to the system. Fine? So this is what is your total precision agriculture thing, which all of us are is known to us. I wanted to tell you what exactly is, how much of amount is being done into that, how much of technology is really being implemented into that, where we are is what is being focused. So the various sensors which are being associated with, so different types of electromagnetic sensors, acceleration, tilt. This acceleration and the tilt mechanism is for the drone. When you are spraying it, at what rate you have to spray, right? At what speed you have to go about and so on. So those things to be, for that you need accelerometers. And also when you are putting onto the UGVs, ground vehicle, at what speed they have to move and so on, okay? basically, these are the sensors which are being put on to the temperature thing, accelerometers, and then your soil health monitoring systems, actuation systems, motors, and so on. So these will be the parts of this. Other than that, these are the sensors which are being generally used for your health monitoring, right? So we use all these sensors. Okay. So this temperatures, and of course they have given it as, we just tell them a temperature monitoring system. There are different types of it. So they have mentioned like what they have used it over there for temperature marking, resistance based thermal temperature detector. So the next one is the connectivity. How are you getting connected? The data which is being collected by the sensors, how is it being transmitted to the controller, human being, or the controller? Okay. So the connectivity plays an important role, wherein you could do it by various technologies. Nowadays, either by Bluetooth, if it is within a small range, distance and so on, you can do them with Bluetooth or Zigbee, or you can use Wi-Fi, LoRa, or you can, if it is for a longer distance, you can use IoT. So that is how the information, first one is the data is being collected using those sensors, and then it is being communicated through these medium. Okay, any one of these medium, they are being communicated. And where the devices which are present over there in the decision making process, okay, you can use generally what is being used by the scholars right now is your Raspberry Pi, which I am supposed to, as you are going to work on, study on to that, it will be easy for you. So either the Jetson board or Open CD, AI kit and so on. So you can use any one of them. So I just gave you that thing because these things will be covered for you in the next session. Let me not take too much time into that, talking about these processes and so on, because that is going to be addressed in separate session. Okay, so yeah, this is how the concept of precision forming is. So you will get some information, right? So that will be, you will also receive some information from the satellites, and you will know the location from GPS and other GIS, the other informations which will be handled over. Okay, so these are all certain numerical data, like your what are all the GIS provides for you, right? And what are all the open source GIS software which are available, so that you can make use of any. I am leaving the PPT also. If you want, you can go through what are all the different open ways, softwares that are available which you can make use of and so on. So with that, I wind up with the precision agriculture. Now we are landing on to the drones part of it. I'll quickly go through it. See, because drones, as you are all aware of, whenever you talk about drones, first thing that strikes your mind is the quadcopter, right? Which you are very familiarized, because nowadays in all the manuals for the photography is going. So that is a nano classification, and I'll also take it down the classification of it. Okay, and we will call them certain times as drones, and we will call them certain times as UAVs and so on, right? So the difference between them, when they are totally automated, you can call them as UAVs. Otherwise, if it is like pilot controlled and so on, you need the intervention and so on. If it is not totally automated, you can call them as the drones. Okay, when they are totally automated, you can call them as UAVs. Okay, and UAS is unmanned aircraft systems. Basically, my research work is onto the systems. I don't build the thing. I don't work on that. Of course, few of my research scholars work on the designing part of it, but more focus is onto the system level. What exactly you put over, the payloads that you put over, the system that you put over, upgradation of the electronics in that. So we work on that domain. Okay. Yeah, this is to give you a flavor of like starting from which size to which size. We call that as UAVs. This also is a drone. This also is a drone. Okay. So from the insect size to a very big bird and so on, right? So all these. So we categorize them based on various things. One is based on the size. Okay. Yeah. So this basic classification, it is the wing system, dynamics of the vehicle. Some of the vehicles, as you can see over in the previous slide itself, they have some rotors, right? Rotating part of them and so on, right? So they are called as rotor crafts. Okay, where you will have a single rotor type helicopters that you see wherein you will have a very big rotor at the top and so on, single rotor type, and you will have multi-copters, right? Multi-rotor systems. Quad is 4, so you will have 4 rotors will be propellers which will be rotating about. You have 6 hexa, 8 octa, and you have different, based upon the payload, how much it has to carry about, you can increase the arm width, the propeller size, number of propellers, all those things you can keep increasing. Okay, so that is about the wing. And when you have a wing-like structure like our conventional aircraft and so on, we call that as a fixed wing tubes. That is a different technology. Totally, the dynamics of the system will be totally different. The rotorcraft dynamics will be totally different from an helicopter dynamics. Okay? A fixed wing vehicle and that rotorcraft will be totally different. Okay? So there are advantages and disadvantages of having vehicles on rotorcraft type and having thing. I cannot go into the dynamics of it. Just I can give you a glimpse of like we go in for the rotorcraft type wherein whenever you want to have an stars sort of a thing. When you want to have a rovering capability, that is rovering capability that you will keep flying at the same time. That is not possible with a fixed wing aircraft. You cannot keep a fixed wing an aircraft which is flying. You cannot keep it at one place, then it will immediately fall down. Right? You cannot have that. So it is the rotorcraft which you can make it. So for all our applications where you want to take a photograph at a particular place, you want to doing a spraying and so on, and similarly at a low altitude and so on, the application, the vehicle which is dynamics which is suitable for this is photograph. That is why we have more of the copter type of UAVs or drones for these applications. Okay. Yeah. So that's what I said you with the wing system technology used, whether it is fixed wing or drone type and so on. Level of autonomy is what I said you like. Whether it is, you can call it as a drone or you can call it as how much autonomous it is. Whether it is totally decision making, control, everything is autonomous, or you need an intervention to give a command and so on. So those things, the level of autonomy, right? Size of it, as I told you, right from an insect size to a bigger bird and so on, right? Based on that you can classify the weight of it, the weight of the vehicle, as well as how much is the weight it can carry about. We call that as a payload weight. Right? All together is what we call it as an all-up weight. All up, how much it can take up. That we refer to as an all-up weight. Right? How much is that weight? Right from grams to so many hundreds of kilograms. Okay? So classification based on the weight. And the energy resources. Ultimately to fly you need energy. Right? Whether it is going to be battery operated or you have an engine system, what type of system it is. Okay? So based on that, or you can have, and nowadays we are moving on to hybrid, where you will have an engine type as well as battery operated engine. Because battery operated things, the endurance that you can have over a period of thing once when you charge the battery will be limited. The time of flight will be limited. Generally for about 10 kg or so on, it is like they might be using about 16,000 mAh battery, which will be it can fly about 10 to 15 minutes. That's all it can have most. Again it will come back, you have to change the battery or remove the battery and put it in the other way. And charging will take again 15 to 20 minutes, of course it will take. And you have to replace it, and every 15 to 20 minutes you have to keep. When you want to have a surveillance which will be having a long endurance without charging and so on, if you want to have it, then we need to go in for this other way, wherein you will have an engines. Any type of a fuel, petrol type or any other fuel that you can make use of based upon the technology, right? You can have more hours of endurance. You can keep flying, right? But anyhow, for the other electronics associated with this, you need a battery. So you will have, and that could be will act as a redundant source also, source of energy also. So it is like you will call that as a hybrid system.
Relay node, but basically the cluster can't be translated.
May I know? Yeah. Who is? I thought somebody is asking for any doubt. It's okay. Fine. That is how it is: single rotor, multi-rotor, fixed wing. Ornithopters is like a fixed wing only. So it's wing only, but it's not fixed. You can see like birds, it will be flapping wing and so on, which we call it as ornithopters. It is literally like birds, the wings will be flapped. We will also call them as flapped wing vehicles. Okay, we have different technologies associated with this, and a hybrid VTOL. VTOL is vertical takeoff and landing is what we call it as VTOL. It can take off like this and it can land like this. Your fixed wing, you cannot have it. It is an STOL. It is steam takeoff and landing. You cannot have fixed wing, the bigger aircraft which we are using and so on, that you cannot have it this way. You can have only this way. You can take off and landing, you can do it in a steam. So that is an STOL type. This is in VTOL type. Vertical takeoff and landing is possible in this contest. That is very important, right? You cannot have a runway for every agricultural farm and so on. So this will be very much useful. For these reasons only we going for the drones, copters as the application things. Second important thing, the characteristics in the level of autonomy, that of course, whether fully autonomous or to be controlled by a remote pilot. So that decides upon it. So size, weight, these things of course. So this is the classification. The more multi-rotor copters, fixed wings or single rotor helicopter, rotor and bigger size. And then fixed wing hybrid VTOL sort of applications. Okay. What are the advantages of it? Of course I have covered everything. What are the disadvantages of it? That also I have covered. As I told you, you cannot have it as in vertical takeoff for your fixed wing and so on, right? You cannot, endurance, you cannot have a longer time for a rotorcraft, whereas for aircrafts you can have them for a longer time. So combining some of the features, we get it in the hybrid mode and so on. And how much of training is required to fly that vehicle? Ultimately, that is very important. No? You have a vehicle, but if you don't know how to drive it, then that is of no use, right? So how much training is required for flying those vehicles and so on? Your fixed wing type is the training requires much more manual human resources, so it is a little bit difficult. Whereas this things easily anybody now school students are all flying, right? So it is very easy to fly about and so on. Okay. And the other classification is on the size of it. As I told you, 200 grams, 500 grams, and even less than that. We will call them as the nano drones, or you can call them as very small drones and so on. Micro, somewhere below 2 kg, you can call it as micro. Small drones, right, up to 25 kgs, you can call them as small drones. 25 to 150, you can call them as medium drones, and 150 plus, you will call it as larger drones. And the certification which I mentioned you by our department, our Center for Aerospace Research, they are giving it on small and medium drones up to 150 kgs. You can fly from 2 kgs up to 150 kgs of that. For that they give a certification. So with that, it's like a driving license, you will say for heavy vehicle, car, two-wheeler, four-wheeler, like that you have a category of certification also, for which you have been certified to fly and so on. So you have those things. Fine. The next one is the very important thing. Classification is based on the range, to what range, the distance covered and so on, right? So that is also important. That's what I said you, like you will have a few hours, minutes and so on, which you can extend it. Based upon that, how long you can have the flight, that depends upon, that decides the application, right? And so on. Power, of course, this also we address. Either it is battery operated or fuel operated and so on, engine based, and you have even fuel cells and solar powered in the wings. You can fix up the solar power and so on. So based upon the power, the source for energy, you can classify them also. Okay. So when you take up and for agricultural purpose, what we use is either the quad or your multi-copters. Quad, Ixa, octa, that's what is being used over in the agriculture. So what are all the main parts of it? When you come over there is the motor, the frame to which things are fixed, motor, electronic speed controller, propeller, battery, flight controller, receiver. So these are the parts, right? Frame is the structure, right? And your motors are the one which rotates the propellers, right? When the propeller rotates, you will have an airflow which is being, the dynamics which is being managed in such a way. Two will be rotating in a clockwise direction, the other two will be in anti-clockwise direction, so that they will generate a lift force with which the vehicle will be lifted. So how much it has to lift, how much weight it has to lift, based on which you will have a variation in the propeller size, motor size, all those things. Okay. So based on which you have to design how much should be the payload weight, based on which you will design how much is the, there is a separate design procedures are available, which wherein you can calculate how much should be the propeller size, what should be the pitch of the propeller, different types of propellers are available, what should be the material of the propeller, what is the motor that we do. All these things nowadays, whatever we are using, we are all using VLDC motors. And as you are all aware of the advantages of using VLDC motors, we are into that, all these avionics things, UAVs, they have VLDC motors. Okay? And so whenever it is a VLDC motor, we need a controller, speed controller for it. So that is an associated part associated with this. So based upon the speed variation only, you can have the maneuvers possible with the vehicle. Like you want to have a turn, you want to pitch up, pitch down, or you want to have a roll and so on. All these maneuvers are possible with varying the speed of the motor, right? So when you want to turn in a particular direction, you will slow down that particular side, two motors you will slow down, and the other side you will increase the speed of the motor so that you will have we will have it moving somewhere for classroom. I think announcement is being given. So it will keep pushing, move on and so on. So the other direction. So in which direction you want to move, you have to reduce the speed of those motors, increase the opposite side motors so that you will have a push force which will push in that particular direction. So that is all dynamics associated with that. So quadcopters, so for agricultural applications, you will have somewhere around this size and so on. And this is what we call it as the 6 rotors things, hexacopter, and there could be 8, which we call it as octocopters. So the number of things that you keep increasing, the complexity also keeps increasing about it. Okay, so these are typical copters which are being designed and supplied by various organizations. Even as I said you, in our own department, and my students are also running entrepreneurs. So they are also running, they are building up and they are providing it. The beauty with that is they also provide with the software. You have a mobile application which will tell you how to do about. Within a day they train. Within 2 days they train an illiterate farmer, literally illiterate, just knows about, like seeingly, if he can understand a little bit of IQ is enough, they are able to train a farmer who can make make use of this. So when the youngsters is there, when they are well versed in mobile applications nowadays, they are able to manage both with this vehicles. Okay, so it's so user friendly app they give it over. So which will tell you how to do this. Work is being done within maximum. If it is an acre of land, they will do that spraying within 4 to 5 minutes. They will finish off the spraying. But you have to do that startup for about 10 minutes. So that is where the training is required. Like where to where you have to do a mapping, right? If it is in a full 1 acre, how do you want it? In what fashion you want to do that? I'll show you with the pictures, right? Whether you want to do them as a straight lines or this way or in a cross way and so on. And if there is a post in between, there could be posts in between the line. There could be a big tree and so on. So you have to fix that particular obstacle. Since that it is known, so there is an obstacle at this point. So the drone, when you fix up all these things and keep it in an automated mode, and you can be hands-free, that will do about, it will avoid the obstacle, and to the next extent nowadays, it's all being additive parts. Now it has been automated collision avoidance system is there, so that if some dynamic obstacle comes into, I know that there is a tree in there, there is a post in between, so I have designed it and so on. Suddenly an obstacle comes and so on. So that could also be sensed and avoided, because we have these toy vehicles, right, with ultrasound sensors and so on. Like that you have designed they are being designed with the collision avoidance system, which will detect about the dynamic obstacle that comes into the part, and they will avoid it and so on. They give a warning alarm and so on. Those things have also been come into the things nowadays. Okay, so I've already spoken about, and this control is having a transmitter and receiver unit. Okay, you will have a transmitter and you will have a receiver over there, with which you will do a control of all these things. Okay, yeah. So this is a typical flight control which is being put over into the vehicle.
It is started for multi-factor incorporate various stages to ensure optimal routing.
So flight controller,
business function
the flight controller, these are all the few conventional market available flight controllers which they are using it on upgrade drones. Okay, so indigenous things comes into over here nowadays. No, earlier it is like still about, we could say about in research that we get the parts from various countries, we do an assembling and we do it. So indigenous is making our own motor, making our own control board and so on, right? Of course our scholars are working on that, right? They are generating a software for that, right? Right from the scratch, from the processor, how to build a board and so on. So people are doing all that. But then these are all market available, commercially available boards which work on that, okay? Like controllers. Yeah, this is with the battery. It's based upon how much is the payload and so on. If it is for spraying purpose and so on, it could be like 6 liters, 10 liters, 15 liters and so on. So based upon how much time you need and how much you have to carry about, it will be like 16,000 mAh to 22,000 mAh. It will vary about in the package. Okay.
Have you used the equipment?
So I'll skip off all these things and try to finish it off within 5 minutes. Our distribution board, how they are being distributed.
Distance, have you used the DIG equal to
This is the software.
Right.
R2 pilot which is being given over with that DGA software. It will tell you, you have to select the particular land where you are going to do the spraying or whatever it is. You have to fix the starting point where you have to do about, and you have to decide the fashion in which you want, row wise or horizontally or vertically. It will have the all the options available. You can select them in that way. If for an example you want to do it in this way, not in a conventional way, you can fix up the design in which you want to do about for many reasons. You can design the fashion in which, so you can fix up the waypoints where it has to move about and so on. So it is your starting point, it will do about. So it is being designed, the app is being designed in such a way that you have been doing about spraying it to a particular point and the fuel gets at some point and so on. It will keep hovering about and you can ask the vehicle to come over to the starting point. So it will automatically give an information and then it will come over to the starting point. Once when you load them, back to the point where it has left, break point. So it will continue spraying right from the point where it has stopped. So it will reach over there and then it will keep continuing job. So nothing will be loosed over and so on. And how much is the width to be covered? See, first line it is going over there, the next line at what width it has to do. That depends upon the size of the vehicle. Size of the vehicle, size of the plant that is, and so on. You can decide at what length and width you want to have that capacity and so on. All those features can be designed using the software, which you can do about. This is actually in video, but because of the time, just not on starting. So you will mark up the place, you will fix up what is the boundary, you can select the obstacle, right, what sort of an obstacle it will be, whether you want to have an obstacle of circle thing and so on or square thing, the shape of the obstacle boundary area also you can fix, and you can fix them all in the mobile that is being fixed to the controller. You can fix up all the things, what type of an obstacle will be, how long you want, how, in what fashion you want, everything could be designed by this. I think I could forward it. இப்படியே ப்ளே பண்ணுங்க. So the way in which it has to be done, that you can fix up, so that how will it move and then it will return, like how it will do in surveying of the land and so on. I'm sorry, I will skip off this video. That is how it is being done, right? You can design everything into that and you can do about it. So now moving on to the final part of my presentation, that how whatever we have been discussing about, what is the research work that we have, our team, research team has carried out. Okay, so it is like, it is one of my scholars work. It is by Mr. Dr. Sudhir Kumar Nagotu. He is my research scholar who has completed. He has got his degree also, and he did this work on research work titled "The Development and Implementation of IoT-based AI-powered smart irrigation system using UGV and UAV." Okay, so he has done design of both the vehicles, UGV as well as UAV, ground vehicle and as well as aerial vehicle, and then the communication of it and the data processing of it and so on. So that is what is that. So irrigation, let us, when we put on all technologies into that irrigation, we can call that as a smart irrigation. Okay, so he was doing it on smart irrigation. So what are all the advantages and the solutions of it and so on. So smart irrigation in the sense like weather-based smart irrigation, IoT sensors for smart irrigation, UAV. So that is how it is being justified that it is a smart irrigation. Okay. So monitoring type, what are all the parameters which are being monitored as like the soil monitoring, plant monitoring, environmental monitoring. Soil monitoring, what is the moisture level of the soil, what are all the nutrients of that, and what is the present condition of it and so on. The surrounding air, humidity, what is the temperature. So they are all that other data which is being referred to that. Plant monitoring, like from the UAV you capture a picture and you see to the health of the leaves and so on, the fruits or vegetables or whatever it is, flowers or whatever it is, what is the health of it and so on, the leaf condition and so on. Seeing from the top, seeing from the bottom. Okay. And then environmental thing, that's what I said you, to get about the weather conditions, whether you will have rain after 3 days or rain after a week or so on, based on which you can do the irrigation and so on. So that is what is he concentrated on to. So designed in UGV and designed in UAV, and then UGV designing is one part of work and UAV designing is one other part, then connecting it to IoT and AR. That's what is being finally being done. So this is the UGV which he has designed about, which can rover about in that particular land. Accordingly, he has designed the green systems. So he has designed it, and he had a soil moisture sensor. When it keeps moving, still we have that technology. The thing is that at various places you will have sensors, right? So it will sense and then it will update it in IoT. Instead, we have optimized it by having a vehicle, wherein you have only one set of sensors, which where the vehicle keeps moving about, dig into the thing, and then it will see about what is that, and then move on to. So the same vehicle will be doing it by lowering the amount of sensors that is required and so on. So that is where the application of UGV comes into. Otherwise, that other technology is also available. If it is a very big land, you can buy and then you can at different places, you can have the sensors which will see about the data, and then it will update it through IoT to the cloud and so on. So those things are available. Now that is being done by UGV. So for which you need a controller through Wi-Fi, and he has also developed a mobile app through which the farmer will be indicated. Right, he will be given a warning based upon the current situation and so on. So this is the way in which he has designed, and this is the dipping mechanism, right? So it will move on into the soil to find out the moisture content and other things and so on. So SRO operated dip, all these things he has designed on his own, so he has also applied for the patent. So I cannot talk too much into that because the patent is yet to be granted and so on. It is in the process. So let me not talk too much into the other design aspects of it. So in a typical UGV vehicle for that particular land he has designed, and simple basic circuitry that is being used over. So he was doing the weather data, obtaining the GIS, using the GIS to get out the weather data, and this is how he has named it as MIT app. So for which how the window will look like in the mobile and so on. So it will give you the guidance moving about and so on. So he has used in deep learning algorithm. So he has used in different test cases with that, in various cases of temperature, humidity, moisture and so on, and in the data, weather data, the next 3 days, next 7 days, based on which the motor is being controlled, whether the motor has to be switched on or off. He has done a test case and actual case. So more or less they go together. Okay. So this is how he has trained the decision tree for the rules of it, like how much the condition about and so on, and what should be the decision overall it has to be taken about and so on. So when the temperature is low, how about the humidity, how about the horn, and the probability of rain, based on which the motor status will be decided on. So he has done and work on that, and he has collected on various days. That's what I said you. For all the cases, you will not have the database, right? When you are doing it for a typical application, you have to generate your own database. So over a period of time on different seasonal things, rainy days, sunny days and so on, he collected winter and so on. He collected data from his own form, and he has created a database with which he has implemented the other learning algorithms. Okay, so he has given a comparison and so on, and finally he compared with whatever is existing, and he has proved like how he has contributed to the research and so on. Okay, so this is the UAV which he has used. It belongs to the smaller UAV category, with an around a payload of all a weight of 2 kgs and so on. So he has done a thing, and he did it for a typical tobacco plant. He has done in stress management also, analysis of the stress of the plant, and then decided based upon the thing. As I told you, as he has gone for a patent, I am not talking too much into that. I will just give you an overview on that. And he worked on various, for volume of research work, obviously when you propose also you have to compare it with various things, and from the research scholars point of view, right? You have to give a volume. So when you propose something, you have to compare it with the existing. So he has compared it with various other existing models, and then he has given a comparison of how this particular thing works with respect to them and so on. So that database and so on.
Effective on searching the optimal clustering configuration, and it
is a video game. So he has did an analysis.
is based on the environmental conditions or thereby helping the adaptation.
So he did it for from 20 to 21, 22, 22, because he was doing a research for about 7 to 8 years. So he collected data based on which he has validated his work, and he has proved how much is the, from his irrigation concept, he has proved how much been reduced, the amount of water is reduced on comparison with all the conventional hand utilizing drip thing and smart way, weather based, with all those things he has compared and proved that it consumes definitely a lesser amount of water, and with a better yield he is able to demonstrate. Okay? So these were his key findings which he has contributed finally, and the contributions, like when you do a research work, finally you have to say like what is the contribution from the technology side that you have done, like what is the innovation that you have done out of your research, finally how is it useful to the humankind, right? So to the general public, what is the contribution that you have done out of your research, that has to be justified. So he has made all these things, study on to what is the knowledge based contribution has done, technical based thing, and finally to the society, how is it being used. Finally to the farmers it is implementable, so it goes to the society. Okay, so obstacles, of course, as we have been discussing throughout our discussion, these are the things, right? The app so friendly, and nowadays everybody is so much used to the smartphones, they are able to make use of it. They were able to make use of it. Okay, so the probable strategies to implement that. Consolidation plan. So, like for the small farmers, how you can make out of it is few farmers together in that area, they'll be having a society. So that society can procure it and could give the service provided available for all the farmers and so on. That way you can make it available for small farmers and so on. So because as of now the technology is like when you are going in for somewhere around a quadcopter, with about a capacity of carrying about 6 to 10 liters and so on. The vehicles procurement cost itself goes about around 4.5 lakhs, and then you need to have the backup, other redundant batteries and so on, all put together comes to about 6 to 7 lakhs. When you go in for hybrid vehicle, it is about 10 plus lakhs, which cannot be afforded by a small farmer for is one or few acres of land and so on. So that has to be brought in. So that is what I said, with the cutting edge technologies being brought into this domain, and right now one particular society can have it, and so that it will be used by others and so on. That way you can reduce the cost of it. Okay. Yeah. Way forward. Finally, conclusion thing. So work on the cost-effective technologies. So that is very important, right? We have to try to reduce the cost of it. We have to bring them the cost of it. Focus on environmental protections and conserving our natural resources. All these smart things, precision things and so on, we have to keep in mind. We should conserve our natural resources. With that, we should not harm them, and we have to make it cost efficient. Okay. So with that, I conclude my presentation. I'll just open up a paper which again deals with the same thing. This is because it is the paperwork of my own scholar who worked on the same area. So I'll just open it there and show you. With that, we will have a discussion. Okay? Any doubts? Actually, I don't have this journal publication. I could not get it. Suddenly, when they said it is, it's okay. It's being published. It's some Springer publication, of course. Yeah, some Springer Science Journal, right? Actual work is not available. So it is low-cost smart watering system in multi-soil, multi-crop environment using GPS and GPRS. That is what he has focused in this particular research paper. So yes, this is the initial work. When he started the research, he has published it. So it doesn't have all the final contributions, because as I've told you, the final thing, since we had been planning for a patent thing, we didn't publish in between. Because the requirement has been met, he had some 2-3 publications. So with that we stopped, and we reserved the innovations for the patent thing, which is under process for that reason. Okay? So this will have the first level of work that he has carried out, which he has built, and hardware kit for the robot, that ground vehicle UGV that he has planned. What is the hardware that he had, and how he was doing the sprinkling calculations, how he has done, and he has built on. So this is not the vehicle what he has built. So this he has taken up as a model with which he has built his own vehicle, which I have shown you.
It's not time out.
Location of unknown node is
So he has done that segmentation based upon how he has done that the total area, agricultural field divided into, depending upon the crop and other things, how he has done, how he has integrated the weather data into the things, how he integrated them, okay? And the algorithm, like what I said to you, like integrating all these things, how he has concluded about it. So this was his initial level of paper. Anyhow, if required, I will also share the other, the next level of publications which he had. Okay. Yeah, with that I wind up my presentation. Any doubts, any clarifications, please?
My basic question is that what is the difference between drone and the UAV?
Yes, sir, that's what I addressed during the thing. It's not much of a difference. Like when you make it totally automated, you can call them as UAV. If the pilot intervention is required, you can call them as the level of autonomy, based on which you can classify them as drones or you can classify them as UAVs. Because it is not with the dynamics.
Some technology they are called as UAV, some of them they are called as drone.
Yeah, that's what interchangeably you can make use of. But then I will prefer what is being used by all our what we call it as like not the licensed trained people who are doing it. That you can call it as drone because the autonomy level is a little bit different, where you need the intervention of the ground pilot and so on. UAV you can call them, which you can put on to the total automation. You can start and you can leave it, it will do the job. When you want to design it, it will finish off and it will come to the point where it has started. If you are putting on into the total autonomy mode, you can call it as UAV. Otherwise they are one and the same. Yeah, any other doubt? Okay then, hope I would have conveyed at least some of my students' research work. I don't know how much I have justified. So if it is really useful, motivate your students who are working on that, okay, to motivate them to do about work which will be useful for the agriculture. We need and sustainable agriculture. So they could take it this as in the passion they could convert it to, because everybody is having a passion of flying nowadays. So let them convert it into their profession, do contribution to that and so on. With that, I finish off my things. Thank you. I had some other videos also. Time is exceeding, so I will thank you. Thank you very much for maintaining silence and keeping over the full session. Thank you very much. Thanks.
On behalf of E&I Department of Annamalai University and on my own behalf as a coordinator and Shaktil sir, I thank Madam Dr. G. Anitha for his exhaustive presentation over drone technology. Thank you, ma'am.